Yes, now I am sure I clicked on start button and then start from the beginning to enable the ones they couldn't attend to this online meeting. Okay, the chapters in the content of this week, and also it is in the content of the course, is about gears. Okay, gear is in English. Okay, the name of what? The name of a machine element. In Turkish, we say dişli çark. Shall you learn the names of the machine elements or machine components in Turkish? Is it a must? No, since the language of instruction in this course in Middle East Technical University is English, it is required. Learn the things in English. Well, although it is so, why I wrote the Turkish names, Turkish vocabulary, trying to extend the vocabulary in Turkish. Well, considering the case of the measure of the students, okay, probably they will find a job in Turkey, Turkish industry, Turkish market. Well, since in Turkish industry, well, the majority of almost all of the technicians can speak in Turkish only. So to be able to communicate with the technicians, then, well, you should know the Turkish words, the words in Turkish in the technical jargon. That's why I'm keen on opening the parentheses and then say that in Turkish this, in English that. Okay, so for inexistence of the words in Arabic in Pakistani language, although I know that lots of students are from Arab countries, the others either India or Pakistan or Bangladesh. Well, since I don't know the jargon in technical word in Arabic or the other languages, sorry, I can inform you only on the Turkish vocabulary. Okay, well, here is a machine element. Well, I said one more thing before starting to record the things. Well, some persons said that in the English alphabet, this letter is written, is read saying G, A, B, C, G. Well, this word attempt to read saying gear. It is wrong. Do not say gear. It is a wrong pronunciation. Okay, in the accent, say gear. Okay, in this wallpaper, there is a photograph. In the photograph, we have gears. Okay, well, this is customized. Since there is a hub at this side, it is not in common shape, but it is a customized gear. It is a helical gear. Okay, this is a spur gear. Yes, helical gear, spur gear. And this is a shaft. Okay, well, this part of the shaft, there is a gear, spur gear. Okay. And see here, there is a keyway. This means this gear is to connect to the shaft using key connection. Okay, this is, I think it looks like sprocket. Yes. Well, not all of, some of the gears. And the remaining time, well, students notice me. Yeah, hocam cannot see the things sharing from my computer. Just check why it is so in collaborate environment. One more time clicked and then share button. And then yes, now I think it is okay. Sure. You see the things from my computer, and this is the wallpaper of the chapter. My presentation, of course. Okay, the chapter is about gears, in Turkish dişli çark. I said that do not read this word. It is the name of the machine element. Okay, it is very commonly used machine element. Do not say gear, but say gear. Okay, and in the wallpaper of my presentation, I said, well, since some of the students couldn't see the things from my computer, that's why repeating the same sentences. Well, there are some gears, not all of them. This is a helical gear. This is a spur gear. This is a spur gear. This is a shaft, okay, specially designed with a segment over there. We have spur gear, okay. This is another shaft. This part, there is a spur gear. And this segment of the shaft, we have a helical gear. Okay. Yes, is a machine element. It is used. Well, like bolt nut pair, in gear, one gear is useless. Need to use a gear with the other one as mated. Okay? In the gear terminology, yes, the one of the gears, most of the cases, must be smaller in size, the other one greater. And yes, as it is illustrated here, two gears are mated and used together. Okay, one gear is useless because we use the gears for driving the other shaft. Okay, well, say that this is the shaft of the engine. Imagine that there is an engine over here. Say that this cloud is an engine, internal combustion or electrical engine, whatever it is. Okay, and this is the output shaft of the engine. And well, at the part of the segment of this shaft, what we have a gear. Okay, using this machine element can drive the other shaft. Here there is one more shaft. Of course, it has the necessary gear, and the gears have been mated. Well, you see those like teeth. Yes, these are called teeth. Okay, this tooth of this gear, well, within this space between the two successive gears of the other, teeth of the other gear, okay, it has been mated. And while the shaft is being rotated by this driving unit, engine, okay, in this direction, while this tooth will exert a driving force onto the tooth of the other gear. And this force will rotate the other gear, of course, together with the gear, the coupled shaft as well. And at the end of this shaft, what we have a mechanism, say that machine, rest of the mechanism, machine, okay, there is a machine, there is an engine. This is an engine, okay, engine, this is a machine. Our purpose is to drive the machine, run the machine. Machine is an excavator, machine is the mechanism of an automobile, machine is the mechanism of an aircraft, whatever it is. Well, there is a mechanism here, it is to do a certain useful work. Okay, and this is what? This is in pair transmission part. The power from the engine is to be transmitted to the machine. And that power, you know, means the energy per unit of time. Energy is needed for the necessary work. Okay, if there is energy, then you can do a work. Okay, you can convert the energy to work. Machine is for achieving realizing such a conversion. Okay, the energy is converted to work. Okay, we have a force, and then force displays, you know the definition of work. Force, magnitude of the force times the displacement along the line of action of the force is the work. Okay, done by the force. You know this. Okay, well, I said that in the pair gear set, it is a gear set, one of them smaller. Answer the question why it is so, why it is smaller. Talking about what it was the time in Mach 100, already answered the question. Introduction to mechanical cause. or say talking about key connections, probably deliver similar sentences. Well, such a set is a torque amplifier from another point of view. Okay? Well, to be able to amplify the turning effect, which is set by the engine, to have a greater turning effect at the machine side, yes, it is a must. At the engine side, the gear is to be smaller in size. At the machine side, okay, well, the other gear must be greater. Smaller size gear is called pinion. Yes, here it is written pinion. And the larger one in size, and it is a set, in the set it is the other mating gear, is called wheel in the jargon. Pinion, and it is wheel. This is called pinion. The other one wheel. In Turkish, pinyon dişlisi, pinyon ve onun çarkı, çark. In English we say wheel. In Turkish we use this word çark. Both of them in general in Turkish, dişli çark. Okay, for the set, well, the bigger one is called çark, smaller one pinion. In English, bigger one is wheel, smaller one is pinion. Okay. To be able to understand or see the advantage of using a gear set, well, it is classical. We start from friction wheel, friction wheels. Well, for the same purpose, assume that, well, in the transmission part, at the transmission part in the mechanism, we have two discs, smaller disc, larger disc in size. This is the engine, and here, this side, we have a machine. M stands to say machine. Okay. Well, we make the distance between the shafts, okay, this distance, say that L, small enough to be able to have a tight touching in the rim of the wheels. The rim of this wheel is tightly touching to the rim of the other. So, well, because of the tight connection, tight contact, well, by the engine, whenever this shaft is rotated or tend to rotate in this direction, okay, say that clockwise direction, well, at the mating part, in the rim of the, say, gear and the rim of the other, these are in contact, friction forces appear. Okay, say that the free body diagram of this disc. Well, in this direction, observing the wheel, okay, it's a disc, say, well, there is a moment vector, okay, if the moment is with respect to the axis of rotation, then it is in the jargon called not moment, but torque, okay? Yes, and to say that torque, you know, from Mach 100, Introduction to Mechanical, it was in the content of last week. I already talked about the turning effect of forces. To be able to say that the vector is not a force vector, but moment vector, we show the arrow with this banded curved one. Okay, now here, observing the shaft together with the associated disc of cones in such a direction, I see the arrow of the moment vector as a dot. Here it is, and it is banded curly arrow to say that it is a rotational effect, it is a moment, it is a torque. Okay, that this is the torque applied, capital T, saying capital T using this letter, I mean the turning effect of the forces which are applied by the engine. Torque of the engine, T sub E. Okay, and well, here at the point, it corresponds to this contacting edge in the rim. What we have an inclined force. okay, it is exerted by the larger wheel onto the smaller one. We resolve this force into two components, tangential component and normal component. Okay, say that normal component F sub n, tangential component F sub t. Well, tangential component, is quite common, called friction force. F friction, F sub F, friction force. Here, tangential component of the force, okay, it is applied by the larger wheel onto the smaller one, is the friction force. And for this friction force, the limit, static friction coefficient times F sub n, the normal component. Okay? You know this quite well, the static friction coefficient. Okay, now, well, the torque applied by the engine is balanced by the torque of the friction force. If, of course, the shaft is rotating with a constant angular velocity. Omega is the angular velocity. Angular velocity of the engine shaft. Okay? Angular velocity of the machine shaft. To say angular velocity of this shaft, I'm going to use this in this. M stands to say machine. E stands to say engine. Okay? This is the engine side shaft. This is the machine side shaft. Okay. Angular velocity, remind you, is equal to 2 pi times number of turns about the axis of the revolve, but it is rotating, okay, per minute. To convert the unit of measurement to per second, we'll say divided by 60. 1 minute is equal to 60 seconds. Okay, omega. Number of turns of the engine shaft, for instance, 2000 RPM. Unit of this is, revolution per minute, RPM. Okay, now the unit of this is radian per second. Okay, this, remember, I think, this famous expression. To be able to find the torque, which is to be exerted by the engine, okay, T engine, okay, is equal to angular velocity of the shaft, engine shaft, okay, so sorry, power of the engine, not torque. Power of the engine, it is to be input, to be supplied by the engine to this part of the mechanism, is equal to angular velocity of the engine shaft times the torque, okay, which is the turning effect of the forces exerted by the engine, torque engine. Okay, well, if we neglect the resistive turning effects of the bearing forces, here there is a bearing, there another bearing, okay, and at the contact surfaces we have friction forces. Okay, their turning effects will be in the opposite direction. Well, for a while, neglect the moments of the friction forces which are at the bearings. Okay, only consider the turning effect of this friction force, this component. It is moment is equal to F friction, F tangential component, it is the friction force, and the maximum value of friction force is mu times Fn, times the radius of this wheel. Okay, while the radial coordinate for the friction force, okay, is the radius of the wheel, the radius of the engine side wheel, R sub E, okay, is the torque of the friction force. This torque of the friction force is equal to the torque, okay, of the forces exerted by the engine. If there is such an equilibrium, then the shaft will continue to rotate with a constant speed of rotation. There will be no acceleration. Okay? So, well, for friction wheels, yes, this is the free body diagram for this smaller wheel. If you draw the free body diagram for the larger wheel, yes, this is the action of the larger wheel onto the smaller wheel. And this is the reaction force, tangentially directed component of the ring force. It is exerted by the smaller wheel onto the larger one. So at the same mating surface, this is reaction. The one is the action, action-reaction pair. So the friction force in magnitude is the same. It is exerted by the smaller wheel onto the larger wheel, but its direction is opposite. If we multiply that friction force, okay, with the radius of the larger wheel, it is R sub m, to say that the wheel at the machine side can find the moment of the friction force with respect to the axis of the machine side shaft. Okay, multiplying that moment with the angular velocity can find the power term. Okay, if the wheels are not slippaging, not sliding, because the friction force not reached to its maximum limit, so can say that there is no dissipation here, energy dissipation. The power supplied by the engine directly transmitted to the machine shaft. Okay, writing the power equation expression. Okay, well, clear the screen. It became very crowded and start the show again. By the way, last 2 minutes before ending this class meeting. Okay, well, write the expression. I have already proved that it is true in Mach 100. Well, what is the expression? It is quite famous for friction wheels. Okay, the diameter of the machine side wheel, D sub m, divided by diameter of the engine side wheel, D sub e, is equal to angular velocity of the engine side shaft. It is also the angular velocity of this friction wheel, since it has been rigidly connected to the shaft, divided by angular velocity of the machine shaft side shaft. Okay, and it is equal to what? The torque at the machine side. It is calculated, can be calculated multiplying the friction force by the radius of this larger wheel, divided by torque at the engine side shaft. Okay, if we make the diameter of the wheel greater than the diameter of the other one, this means from this equality achieve to amplify the torque. To be able to have a greater torque at the machine side, yes, always use larger wheel at the machine side, smaller wheel at the engine side. Well, this equality comes from power expression. Power term, write it for the machine side wheel. Okay, omega machine, angular velocity, times torque, Tm. Okay, since there is no slippage, no sliding, the power can be written as equal to angular velocity of the smaller wheel, engine side shaft, okay, times the torque, okay, at the engine side shaft, T sub E. Since there is such an equality, well, angular velocity ratio is equal to torque ratio. Okay. In terms of number of turns, it can also be written the number of turns of the engine shaft divided by number of turns of machine shaft. If not friction wheel, but we have gear set, why we need to replace friction wheel, although it is a very simple mechanism in shape and it is a cheap solution, okay, to be able to transmit power from here to there, use two simple discs. Very simple mechanism, very cheap solution. Why we replace this simple geometry with such a difficult one, more expensive set? Because for the friction force, and it is torque, there is a limit. Mu times Fn is the limit for the friction force. It is the driving force. It is needed to rotate the machine shaft. Okay. Of course, multiplied by the radius of the wheel is the limit for the torque. Okay. Well, the power to transmit is greater than the one, it corresponds to this limit. If this limit is exceeded, then the wheel will start to slippage, and then the power cannot be transmitted. To be able to prevent slippage, have positive contact, not have the connection due to the existence of, thanks to the existence of friction force, but have positive contact. How? Cut the material in rim, create such a channel. Cut the material, create such a channel, and between the empty spaces have such a solid extension. Well, such solid extensions look like teeth, so we say teeth. And after creating these channels, okay, in a special shape, I'm going to talk about it should be, it must be, those must be in which form, well, following video record. Then this means we converted the disc to a gear. Well, in this example, it is a spur gear. Okay, this is the wheel, this is the pinion. If the set is not a friction wheel set, but gear set, since we have a positive contact between the teeth, well, can transmit greater power. For gear set, this famous equation can be extended, adding one more ratio, say that equal to the teeth ratio. Well, number of teeth, 1, 2, 3. Number of teeth, I'm going to use letter Z to say number of teeth, okay, at the engine side, gear, divided by number of teeth at the machine side gear, engine side gear. Yes, this is a very well-known equality. And considering this and that, can clearly see that, well, using a greater sized wheel or gear at the machine side can achieve to amplify the torque, have a greater torque at the machine side. And the greater torque is always a good thing, because if the torque is greater, can have a greater force to balance that torque, and that greater force can do a useful work. Using that force can cut material if the mechanism machine is a cutting machine, or if it's an automobile, can have a greater thrust force, okay, over the surface of the road, and then car can much more easily accelerate it, so on and so forth. Okay, my dear students, I have another class meeting in 5 minutes. And if you're taking that course as well this semester, it is Introduction to Mechanical Engineering course, then, well, you have also 5 more minutes, actually 4 more minutes. Well, ending this video record, okay, and then the rest, you're going to see the rest following this in video format as recorded asynchronous manner. Okay, stop the recording, and then please do